In this video, we'll take a look at how to solve a system of linear equations. That'll be 3 equations with 3 unknowns using the elimination method. If you recall from previous lessons, for 2 linear equations and 2 unknowns, when you use the elimination method, the idea is that you want to eliminate one of the variables by the operation of addition or subtraction. In that case, we need the same coefficient on the same variable, either same sign or opposite sign. If they are opposite signs, then we eliminate using addition, and that's what I will follow through the rest of this example. So notice we have 3 variables in each of these equations, x, y, and z. And so our goal before we start is to think about, well, which variable are we going to eliminate? And really, it can be any one of them. So it's all up to you. I usually recommend eliminating the one that is set up to be most easily eliminated, and that would be one that doesn't involve any multiplication by a constant. However, that's not always the case. So for this case, I'm just going to decide to eliminate the y variable. And I have to use 2 equations at a time. So let's first start by numbering them. We'll call this one number 1, number 2, and number 3. I'm going to work with equations 1 and 2 together using the elimination method to try to eliminate the y variable. And this is done exactly the same way as it was with 2 variables. So if you notice that the coefficients on the y variable, plus 1y and minus 3y, do not match. They are opposite signs, which is good for the addition method, but they're not the same number. So if we notice that, if I were to multiply the second equation by 3, this will become 3y, right? And it will be then matching with the one above. So let's do that. There is nothing to be done with equation 1, so we'll just leave it as is. That is 2x minus 3y plus 2z equals 18. Now the second equation does require a little bit of work. We need to multiply by 3, right? So we have to multiply each term by 3. Let's just move that over a little bit. That's equation 2, and it's going to get multiplied by 3. Okay, each term gets multiplied by 3. So we look at the first one. Minus 3x times 3. That is minus 9x. Plus y times 3, which is plus 3y. Minus 3z times 3, which is minus 9z, equals minus 13 times 3, which is minus 39. Okay, we are going to now perform the addition. And I am choosing addition because I have, in this case right here, in the y term, minus 3y, and I know that when I add to that positive 3y, I get plus 0y, which is the goal of the elimination method. Check. I've eliminated one variable. So now let's work with the rest of them. And remember, you can only add like terms, so we'll work vertically like this. Notice how I have my x, my y, my z, and my constant all lined up. That is very helpful. So let's add these two. 2x plus minus 9x, which is minus 7x. Moving on to the z. Right, like that. 2z plus minus 9z is minus 7z. And we will do the constants as well. We have 18 plus negative 39, which is negative 21. Okay, we have eliminated the y term, so we now have a linear equation in 2 unknowns. don't we? And so let's keep that 1 right here. I'm going to call it A. And it is negative 7x subtract 7z equals negative 21. Okay. Remember, from working with 2 equations and 2 unknowns, if we have a second equation with 2 variables, we can use the elimination method together with those 2. So we need a second one down here. And we get that by working with a different pair of our original equations. So first we worked with 1 and 2. I need to work with 3 and 1 of the other ones now. It doesn't matter whether I use 3 and 1 or 3 and 2 to eliminate the y term. Again, we're still eliminating the y term because we want the second equation, which we're going to call b, to be in x and z. Okay, that's the goal. So I look back at my original equations. I still want to eliminate the y term, and I notice that right here we have plus 1y and minus 1y already set up for elimination. So let's use 2 and 3 now. All right. We will rewrite equation 2, and it is minus 3x plus y minus 3z equals minus 13. And equation 3, okay, it is x minus y plus 2z equals 9. Let's just move this up a little bit. There we go. Again, we're going to use addition. Why addition? Well, if I take a look at the variable I am intending to eliminate right here, the operation that eliminates the y is addition because they're the same coefficient, 1 and 1, but opposite signs. Okay? So 1y plus negative 1y is 0y, and great. Again, we've done it. So we'll use addition for the other terms too. Let's go across there. I like these red boxes. Negative 3x plus 1x is negative 2x. We'll do the z term. Okay. Negative 3z plus 2z, negative z. And we'll do the constant. Negative 13 plus 9, which is negative 4. All right, that's our second linear equation with 2 unknowns. Let's put it over here. We're calling it b, negative 2x subtract z equals negative 4. Now this will take you back to the first time you studied the elimination method. And now I want to eliminate either the x or the z. And so I can do either, it doesn't matter. If I want to eliminate the x, then I need to make the coefficients match. And so I'd either have to multiply the first equation by 2 and the second equation by negative 7. That would get them opposite signs, but both 14. Or if I eliminate the z term, I notice that this one is a negative 1. So by multiplying this one by negative 7, it's going to become positive 7, which will be a 7 like the one above, but it will be the opposite sign. So that's what I'm going to do. We're not going to change equation A, so we will just rewrite A. And it's going to be negative 7x subtract 7z equals negative 21. But equation B, we are going to multiply equation B by negative 7. So negative 2x times negative 7 is going to give us 14x. And negative z times negative 7 will give us positive 7z. And negative 4 times negative 7 will give us 28. Now we will do our addition, and we'll check on the one that we think we are eliminating, right? Negative 7z plus 7z is plus 0z. Let's do the rest. Negative 7x plus 14x is 7x. And negative 21 plus 28 equals 7. So we have the equation 7x equals 7, or x equals 7 over 7, x equals 1. Aha! We have part of our answer, x equals 1. We know that the variable or the value of x that works in each of these equations is 1. Okay? So now we just have to sub this x equals 1 into any of our equations that have only two variables, like this one, or the two above. So let's just put it into equation B. It doesn't really matter which it goes into, so I'm going to write that down. We'll just say sub x equals 1 into, we'll say A or B, okay, just for the note, and I'm going to use B. So 14 times 1 plus 7z equals 28. We will solve for z now. So, and solve for z. Okay, 7z equals 28 minus 14, which is 28 minus 14. 7z equals 14, or z equals 14 over 7, which equals 2. So now we have z equals 2. Some of our answer, the second part of our answer, we just need y now. We choose an equation that has y in it, which is one of our original three. We sub in x equals 1 and z equals 2 into either equation 1, 2, or 3. So let's write that down. Sub x equals 1 and z equals 2 into 1, 2, or 3. Doesn't matter. And then solve for y. And we'll have the y. So I'm going to go back, take a look. I need one of those equations. Which one will it be? Whoop. Let's use the last one there. Number 3. X minus y plus 2z equals 9. All right, let me just write that down. X minus y plus 2z equals 9. Double check that I remembered that. Yes, that's right. Okay, so I'm going to sub in for x is 1, so that's 1 minus y plus 2 times 2 equals 9. We'll say, so minus y equals 9, and I'm going to move the 1 over, so it's a minus 1, and that's a positive 4, so I'm going to move it over to negative 4. I get that minus y equals 9 minus 1 minus 4, which is so it's 4. Or divide by negative 1, which is negative 4. So y equals negative 4. And there's our answer. We have all three. The solution can be written like this: 1, -4, 2. And that's the elimination method for 3 equations in 3 unknowns. Thanks for watching.